Okay, so we're going to do this one using the long division method that I introduced you to yesterday. So we don't have to. We've got equating as an option, but I have to say that I guarantee that some of you will eventually do the division thing in preference. All right? I mean, that's only my experience has told me that. I think if you're good at it, it's quicker than equating. Anyway, so this is a question. We're not given a factor. So the first thing we have to do is find a factor. And so that means reaching for your table function and trying a range of different values and just finding one value that works and therefore identifying one factor. So you're going to use your table function to find one root, and that will give you a factor that we can divide by. Okay? And see what you can do. If we'll probably all agree and use the same one, you'll find some different ones, I'm sure. Okay, so Jodie's saying that f of minus 3 is 0. So, Tegan, what does that mean the factor that we can use is? Well, the factor's in the bracket, so tell me what goes in the bracket.
Oh, it's our
X plus 3, right, okay. Now, you may have found other factors. If we can all agree that we'll use this one, then I can go through the process, because this is only the second time we've met this process. I'm going to talk you through this one, and then I'm going to get you to try a couple on your own. As I said, for factor theorem questions, you do not have to use this approach, but it is an approach you're expected to use. I'm going to look at a couple of questions today where you would have to use it. Well, you know, that's probably not strictly true. You could always use an alternative, but it's by far the most efficient in some questions. Right, so my first question, if you remember, is how do I get from that to that? What do I multiply by? Harry, what do I multiply by?
2x squared.
2x squared, fantastic. And so then I do this multiplied by this, because I want to work out the remainder. So 2x squared times x is 2x cubed. That will always be the same. If it isn't, we've done something wrong. And 2x squared times plus 3 is plus 6x squared. We then work out our remainder. Top take away bottom, nothing. X squared minus 6x squared, we're taking away, so that's minus 5x squared. And you know, we could, when we do bus stop with numbers, we write the remainders before the next digit, don't we? But we're not going to do that. We're going to just bring the next digit down instead. And that cycle is just the cycle we go through again and again and again. It's a three-step process. So let's go through that cycle again. What do I multiply this by to make this? So Charlie, what do I multiply by?
Sorry to interrupt, Mr. Cooper. You know there was some book ones for the year 7's Alps group, some of these
Yes.
running around. Do you know what
They are by Lorraine's area on the bookshelf. Sorry about that. Sorry, Charlie, you were telling me. Minus 5x, thank you. Yeah, minus 5x, brilliant. So minus 5x times x is minus 5x squared, and minus 5x times 3 is minus 15x. So Isabel, when I do my taking away, that's going to give me nothing. This is a bit fiddly. Minus 18 minus 15?
3x minus 3x.
Minus 3x. Minus 3x. Last question. What do I need to multiply that by to make this? Pat, help me out. What do I multiply that by to make that? Minus 3. And you know, we can see there's a pattern to our answer, isn't there? So, you know, I knew that this was going to be a number, just like I knew previously that was going to be some x's, and I knew to start with it was going to be some x squared. So yeah, minus 3. So I've got minus 3 times x Remember, we're holding our breath at this point, because if Jodie was right, if this is a root and this is a factor, I should get 0 remainder. So here we go. Minus 3 times plus 3. Brilliant.
Where did you get this minus 5x there from the first one?
Okay, so I asked, do you mean here?
Yeah.
So we said to get from here to here, we multiply by 2x squared. So then we did 2x squared times that. So 2x squared times x gives me 2x cubed. 2x squared times 3 gives me 6x. And we then work out the remainder by doing that, take away that. So this take away this is nothing. X squared, take away 6x squared, that's where the minus 5x squared came from. So we can now say, okay, I know this is equal to x plus 3 times that. Of course, we haven't finished, have we? Because we're hoping that the quadratic that we got as the answer to our division will still break down into 2 separate quadratics, separate linear factors. And of course, some of you might have seen those an answer when you did the table function. Did anyone?
Minus 3.
So minus.
It's minus 3 and plus 3.
Right. And if that's x minus 3, then I need to get a minus 9, so I just need a 1 there, and I need a 2x. So that was just factorising that to that, which is always fiddly. Factorising with more than one x is always fiddly, but of course if you've used your table function and you found there was more than just one just found value there, so plus 3 for example, then you've got a bit of a helping hand to start you off. So this is our second attempt at driving. All right, first attempt yesterday, wobbly foot on the clutch pedal. Hopefully now we're almost ready to change gear maybe, or go to a roundabout. So I'm hoping that. So just in the books, have a go at page 145, 3 and 4, which we've already done by equating. And they give you the factor, so you can skip the table function step and go straight to the division. So we've already got the answer, if you like, because we did it using equating. Page 145, question 3 and question 4. See how you get on. I don't know if the colour coding is helping or confusing, but I went through the process 3 times. So in blue I asked what do I multiply that by to make that? It was x squared. I then multiplied this by x squared to give me x cubed plus x squared. I then did this, take away this. We're not adding those two things together, we're subtracting them. So that's why that was 2x squared. Brought down the minus 33x. I then asked, what do I multiply this by to make this? And the answer was 2x. 2x times x is 2x squared, 2x times 1 is 2x. This, take away this, gives me minus 35x. Bring down the minus 35, and then in green, the final step, what do I multiply this by to make this? Minus 35. Minus 35 times x is minus 35x. Minus 35 times 1 is minus 35. No remainder. That's the final answer to the question. Then, so here is the solution to number 4. Okay, now the question is, up until now I've said, right, you could use equating, and many of you will say, yeah, no way I'm going to use this. I'm definitely going to use equating. Will I ever have to use just this? Well, strictly no, but you do get some questions that specifically refer to division. And that's where I want to go next. So if I show you an example of such a question. So here, this is just a division question. So it's not a factor theorem question at all. They're just asking us to divide one thing by another. And you could use equating. You could use equating, because what we're saying is that this is equal to this times this. So you could grid that out and do your equating thing. Okay, there's nothing to stop you doing that. So, you know, although I'm saying this is perhaps a question where division is more appropriate, you could use equating. But let's keep our nerve. Let's hold our nerve and let's try and do it by dividing. Now, there's one thing that is particularly special about this question, and that is in the thing we are being asked to divide. Can anyone notice anything unusual about this? Well, I think there's probably two things unusual. So we've got a quartic here.
2x?
Well, yeah, okay, yes, we're dividing by something more complicated. There's something missing. There's an x cubed term missing. And this division process breaks when you've got a missing term, because it relies on you having an x cubed, an x squared, an x and then a number. It relies on everything being lined up. So what we have to do in this situation is we have to put a dummy x cubed term in. So what I have to have underneath my bus stop is 4x to the power of 4 plus 0 x cubes minus 17x squared plus 4. Okay? So I've got an x, thank you. I need a dummy x term as well, thank you. Yeah. And yeah, unless we do that, the process is going to break. I say again, you could use equating, and with equating you don't need to put the dummy values in. When you equate your x cubes, you just say I've got none on the left hand side, so I have none equal whatever you have here. But with division, we've got to have them in there. It's only when you watch yourself on video you realise how dreadful your handwriting is. So can I apologise for years of dreadful handwriting for those who I've taught for years. So I'm going to start you off. To turn 2x into 4x to the power of 4, I need 2x cubed. 2x cubed times 2x gives me 4x to the power of 4. So I then multiply. 2x cubed times 1 gives me 2x cubed. I'm then going to subtract 0 x cubes, take away 2x cubes, gives me 2x cubes. Right, go on, you're on your own. Go on then, what comes next, Isabel?
I've got my glasses on today, so. Minus x squared.
So to turn 2x into minus 2x cubed, you're right. Very good. So that gives me minus, that was a fiddly one, wasn't it? Minus 17x squared, don't forget we're taking away, minus x squared. This is where the problems tend to crop up. So that's minus 16x squared, because minus x squared is like adding an x squared. So go on, Beth, what would come next? What do I multiply that by to make that?
Minus 8x.
Minus 8x, brilliant. So minus 8x times 2x gives me minus 16x squared. Minus 8x times 1 gives me minus 8x. Again, this is where the problem's going to crop up. So I've got to do 0 x's, take away minus 8, which is plus 8. We all hold our breath. Here we're going to get 0 at the end. To turn that into that, I need a plus 4. Bingo. So the answer to that question, that was just a division question, is that 2x cubed minus x squared minus 8x plus 4. no need to go on and do anything else. It was just a division question. Have a look at those two. Yes.
And you agree with the fourth toward the end.
At the end. So I asked, what do I do to turn that into that? And you multiply by 4. 4 lots of 2x is 8x. So I did 4 times 2x is 8x. 4 times 1 is 4. And nothing left over.
Are we doing those questions in that order?
Yes, yeah, which is because 13 is another one with missing terms, so you've got to put dummy values in. And then 12 is a sort of division question. So 13 was just 1 divided by the other, needed 2 dummy values, and so the answer was just x squared plus x plus 1. This simplified question was a division. Now, you know, when in the past, when we've seen questions like that, they've been at GCSE and we've had to factorise top and bottom and cancel things out. And it may well be that we could have done that, but with this one, it's also a division sum. We can think of it as a division sum, so we've got that option as well. And so that's the answer to simplify that. 19, if you're on 19, then it's worth persevering with. If you haven't started it, then I've actually put a slightly different question that's almost identical in on independent study. If I can just briefly explain it. We could either substitute in x is a quarter. That's the factor theorem to show this is a factor. But of course, if we do the full division and get 0 as a remainder, then that also shows it's a factor. So division provides us with an alternative to the factor theorem. And I wonder if with a value like a quarter, it might be a little bit easier to do the division. You know, substituting x is 1 into a thing, or 2 or 3. Of course, you've always got your calculator to help you, I suppose. But we know that if 4x minus 1 is a factor, then x is a quarter is a solution. You then get to have to do the division, and you get this quadratic as your answer. And it says, hence show the equation is exactly one real solution. Well, we already know that a quarter is one solution. So what they're asking us to show is that this has no further solutions. What technique do we use to show a quadratic has no solutions? Oh! Yeah, so you can, hopefully when you get an answer, you can show that the discriminant, b squared minus 4ac, is negative, and therefore this provides no further solution. So x is a quarter is the only solution. It's worth finishing that one off if you had started it, and if you hadn't started it, well, you can do that one, or there's a different one I put from the mixed exercise on the independent study page, which asks something very, very similar. Okay, let's move it on a step. I've written 2 really complicated sums over here, which some of you will be puzzling over for some time. We so far have been dividing our polynomials by factors. So we have been doing sums like this, and our answers have been nice, easy answers with no remainder. However, if I'm asked to divide 15 by 4, it is not a factor of 15. So my answer is, well, it's 3 whole 4s, and at primary school we would have written remainder 3. And of course we're not at primary school anymore, so we might do it as a decimal, or we might say it's 3 whole ones and 3 out of 4, 3/4. Or we might say, yeah, well, 15 is 4 times 3 with 3 left over. So we have a remainder. And, you know, I've got a number of ways of expressing that remainder. These are the 2 key ways, I think. 15 divided by 4 is 3 with 3 left over, and that's 3 towards the next whole 4, so it's 3 3/4. Or 15 is 4 times 3, and then you've got 3 left over. So let's have a look at the algebraic equivalent of that, which we will find on page 142, question 8. So here, I've already going to have time to do the first one. It looks like x plus 5 isn't a factor of this, because we're told to find the remainder. I mean, we could use the factor theorem, we could substitute minus 5 in, but I don't think we need to. We're not asking, we're not being told to show that that's not a factor, we're being told. So when we do the division, something unpleasant is probably going to happen. No dummy values needed. So can I invite you to have a go at that one and see what happens at the end? See what happens at the end. So I've got to here, again, I'm just really careful at this point. So minus 3 minus minus 5 is 2x. Because the trouble is with these ones, I haven't got the fail-safe thing at the end that says, right, you're going to get a 0 at the end. So I can't check at the end whether I've done it right or not. So to turn x into 2x, I need to multiply by 2. Two take away 10 is minus 8. So my remainder is minus 8.
You meant to get that?
Yes, that's correct. So I can write this in 2 ways. I can either say that, and I haven't really left myself enough space, sadly. I can either say that x cubed plus 4x squared minus 3x over 2 divided by x plus 5 is equal to x squared minus x plus 2 plus, do you remember with the division sum with 15, I said it was 3 over 4, 4 was what we were dividing by. So in this case it's plus, well actually it's not because it's going to be minus 8 over the thing we were dividing by. So that's one way of writing that answer. The other way of writing that answer is to say, right, so I know that this is equal to x plus 5 times the answer I just got. That's what we've been doing all along. But we've got a remainder, minus 8. Now hopefully you can see that I can move from this one to this one by multiplying everything by x plus 5. And I can move from this one to this one by dividing everything by x plus 5. So there are 2 ways of writing the answer to this, and neither of them are particularly pretty. But I just want to talk about orders. So the order of a polynomial is the highest power of x that you find in it. So my original cubic had an order of 3. The answer to my division sum, the quadratic, that's got an order of 2 because the highest power of x is x squared. The thing I divided by has an order of 1, and my remainder had an order of 0. And you will always find that the remainder, if there is one, has an order 1 less than the thing you're dividing by. Okay? So next year we do this where we divide by x squareds, by quadratics, so you can have remainders which are linear factors, order 1. But because at this stage we're only dividing by linear things with an order of 1, our remainders will always just be numbers.